For example, if you take a 9-volt battery and you put a pen in front of it, what happens to it? Did it blow up? Well, maybe we tried. Well, think about what happens. For as long as you have, what is the battery? A bunch of what? Electrons. Just picture a bunch of electrons and they want to just go around it. The minute you stick what? A path for those electrons, they continuously do what? Circulate over and over and over and over again. So for as long as we do what? We're pumping those electrons up there, they're just floating around. Okay? Very similarly, when we turn a light bulb on, for as long as we're pumping electrons on it, they just circulate through the what? Through the light bulb, and they give us illumination. Okay? So current flows. Okay? But because nothing is perfect, and everything has a little bit of resistance, so there's always some power dissipated on it. So when those electrons, they dissipate into what? Into the filament of the bulb, and it's changing into what? Illumination and heat. Eventually, what happens? What do you do in a flashlight, for example? What do you do in a flashlight? You take a battery, you practically what? Shut it out. Okay? With a little what? Tiny light bulb. The tiny bulb gives you heat and illumination. Very similarly, when you have what? A panel up here, and you're taking and you're shorting it out, what are you going to do? You're going to get a continuous what? Flow of what? Of current. The problem will be associated with that is that you're dealing with what? With physical elements inside of it. So therefore the manufacturer at some point in time will do what? Will have a certain limit before that device starts going to what? Breakdown effect, burns. And the condition with that will happen based on what type of condition? It's also going to happen depending on the amount of what? Radiation you're pumping into it. We cannot always dictate that we're going to get 1,000 watts per square meter. But it might be some days when it's very, very hot, we might get even more. So what happens under these conditions? The current up there becomes what? Much, much higher. Much, much higher. So therefore, at some point in time, based on the manufacturing method, that device might what? Might burn. Generally, for at least in some of you guys who install them and short them out, I don't think, they will burn. However, the manufacturers always indicate that you should not short them and leave them up there. What's going to happen? As long as you shine them, there's going to be what? Continuous current flow. So therefore, you're going to have what? The wires are going to become hot. That's one of all the other reasons that you have what? Such a specific type of installation of those wires. Okay. Good question. Okay. Now, if I look at the specifications in here, that if we plot voltage times current in here, we can actually figure out the condition, okay, that we can get the maximum what? The power point, the maximum point that the power is at most. So if we plot, this is current, which current goes in here increases, versus the voltage increasing here, we reach a point where we call it what? The maximum power point. And that's the point usually that we would like to have the module operating. Okay. Now, okay. This is under what? Under laboratory conditions. What will affect a lot of those things? Well, there's a lot, again, conditions. One of the things is going to be what? Irradiance. The amount of what? Of solar radiation that we get. So a lot of the manufacturers, they will give you a lot of these plots with what? Under different conditions, what? Of radiation. Maybe they do it at 800 watts per square meter, or 900, 1,000, and even more. There's one. So far, so good? Did I lose anybody? Did I lose anybody so far? Hopefully not. We'll do it again. Okay. Now, there's a fill factor definition. And if you look at your box up here, it gives you actually a conditions of what? Of short circuit and open circuit relationship at a different what? Maximum current. Okay? At a different maximum current. And usually this particular area is the area that the actually module itself can operate. Now there's a lot of considerations that would affect this fill factor. So this one, for example, you have the lower fill factor at a different conditions, or an open circuit and short circuit, and then you have actually the other type. How do you measure the short circuit current? You expose the device to the sunlight, and you stick an ammeter up there or the multimeter. Since the short circuit is what? The short circuit current becomes what? What's the power under short circuit condition? Well, it depends on what? Under this kind of conditioning here, you have what? The maximum what? Current. What's the voltage in that? Well, if the open circuit voltage in here and right here, what would be your power here? So if we plot it, you can see the power in here. As we increase, the short circuit current, because the short circuit was shorting it, as we increase in the voltage, you see there's a relationship. So at this point we have a certain amount of power. Here is here. As we're moving up the voltage, even though the short circuit current what? Remains what? Constant, because I'm shorting the panel, right? Shorting the panel. The current up here reaches what? To a certain point, and it's just what? Drops off. Okay? So therefore the power at this particular point, when the current is maximum and the voltage is zero, it's going to be what? Zero. Zero voltage times any kind of current. It's going to give you what? Zero power. Again, the fundamental laws of still thing. Now, in the specifications of a module, and I hope some of you have this thing. Yes? If you look it through, different manufacturers would give you what? The manufacturer's name, okay? Then it would give you the model name. The type of material that the thing is what? It's measured, it's made of, okay? The cell type that you have, and the number of cells that interconnect them, whether they're in series or in parallel, okay? Then it would give you what? The maximum power associated with that. What they call the Pmax. And then the word what? They said something was called warranted minimum power, okay? So this particular case, what does they have? They have that this is what? 185 watts module. And then they have it here what? Warranted minimum Pmax of 179.5 watts. What does that mean? What does that mean? I guess what happened is 185 watts, it's under standard laboratory conditions. Okay. Perfect conditions in the lab. 179, 180 watts is under what conditions? What is it? That if you take this thing in the outside and utilize that, they said that the minimum or the maximum, the minimum power that you're going to get out of it under these conditions, we warranty is under what? 180 watts. Why is that? Because how do they produce those modules? They pop them up what? Left or right. So there's always what? A tolerance associated in the what? In the manufacturing process. You don't do all 200 amp services all exactly the same, right? But they all do what? 200 amp services. But you guarantee the customer's got 200 amps. Some of you might use a 30 circuit panel, some of you would use what? 40 circuit panel. What happens? Excuse me? Power company does the same thing. What happens is that the manufacturer, because you cannot control, and one of the thing is that